All right, 8th grade. So here we go. We're starting on exponential functions. Reminder, a function is an equation or a relation where for every x, there's only one y value. In an exponential function, we're putting the exponent, or in the exponent, we're putting our variable. So let's get going. Maybe. Oh, there we go. An exponential function is a function of the form y equals a times b to the x power, where a cannot equal 0, so that could be a negative or a positive number, it just can't be 0. And b has to be greater than 0, so our b value, the one being raised to the exponent, has to be a positive for what we're working with, and b cannot equal 1. And then x is a real number, but b cannot equal 1. Why? Because 1 to the anything value is 1, so we don't get very far. That's why. Once we make it 1, then it's almost like having a vertical line, or a horizontal line. All right, now these are examples of what an exponential graph looks like. So here's the thing, if you notice, our red lines, either direction that they're going, they do not cross over the x-axis. They get really, really close, but they never cross it. And it's the same with the blue line underneath. They get really, really close to that x-axis, but they never touch it. Why? Because the bigger your x value, or the smaller, if we put negative numbers in for x, right? Negative numbers are going to make it into a fraction, and we're never going to go past our number over here. 1/2 to the whatever power is just going to keep getting smaller and smaller and smaller, but it will never go past where y is 0. So again, it gets really close to the x-axis, but it will not cross the x-axis. So just things to note. Other things to note while you're looking at this, these over here, things that we see, we have whole number a values, right, to, not a values, whole number b values. And then the blue one is that negative a. So a negative a flips us below the x-axis. And so that's something you may want to note for yourself. A negative a flips us below x-axis. But if it's positive, we're going to be above the x-axis. Over here, our b is a fraction. And so if you notice the difference between the left and the right is one is like an increase, right? A positive, so that's where we have the whole number. And our fraction b is giving us a decrease. And we'll talk more about that in a later video. Let's keep moving right along. All right, does this table represent a linear or an exponential function? Explain. So how do we figure it out? We just got to figure out what the pattern is. So linear would mean we'd add subtract by the same number. So if I'm adding or subtracting, in this case subtracting, this is a -2, but this is a -6. So it's not linear. But what would make it exponential? So adding or subtracting make it exponential. Multiplying makes it, or adding or subtracting make it linear. Multiplying makes it exponential. -1 times 3 gives us -3. -3 times 3 gives us -9. -9 times 3 gives us -27. Therefore, this is an exponential function. And the reasoning is our common difference. So up here we're adding by 1. But we have we call this down here a common ratio. So we're not going to call it a difference because we didn't add or subtract. We multiplied it, and so we call it a common ratio. So exponential, and the reason is has a common ratio of 3. That's our explanation. That's what we're looking for. Do we have a common ratio, or do we have a rate of change? Which are two slightly different things. Slope is found in rise over run. Common ratio is what are we multiplying by? All right, example 2. Suppose 30 flower beetles are left undisturbed in a warehouse bin. The beetle population doubles each week. Here is the function. F of x equals 30 times 2 to the x. It gives the population after x weeks. How many beetles will there be after 56 days? So this is the thing I need us to point out before. We just throw 56 in for x. This says days, but x is weeks. So we need to take 56 and divide by 7, which is 8 weeks. So our x equals 8. So now we're going to do f of 8 equals 30 times 2 to the 8th power. And so when we do 2 to the 8th power, we get 256. So we have 30 times 256. And then 30 times 256 is 7,680. So again, the 2 to the 8th we did in the calculator. So that's how we got this 256. Take that times the 30. And so in 8 weeks, or 56 days, there will be 7,680 beetles. Ugh. Beetles. Gross. All right, in the next video, we are going to talk about how to graph exponential functions. And so 8th grade, I will see you in that next video. Until then, stay classy.